So when we're talking about carbon nanotube logic specifically, the dream goal is to one day replace silicon and have carbon nanotubes be the foundation for electronic circuits. And you get significant benefits, orders of magnitudes benefit in performance for logic when you can do that. However, the benefits of these new technologies go beyond simply replacing silicon. Because I think it's important to recognize that there is a lot of time and there's a lot of money and a lot of experience that's been invested in silicon. And silicon is great at what silicon does. There's a great analogy that my advisor used to tell me, which is that silicon is really pasta today. It's rice. It doesn't have flavor. It's there. It's easy to make. Right? Everyone can use it. And the exciting work now is, well, what sauce do we want to put on top of our silicon? And that's exactly what we're doing today. What is more exciting than just having a device that's a little bit better than a silicon transistor is the fact that we can actually build these new technologies right on top of a starting silicon CMOS substrate. So we can start with a silicon chip that we buy off the shelf from any foundry today. And directly on top of that, we can then build carbon nanotube logic. We can put new types of memories on top of there. We can make millions of sensors made from carbon nanotubes right on top of that. And now these new types of systems that are enabled by using these new technologies can not only achieve significant gains in computing performance. I'm talking 100, 1,000x gains in computing performance. But we can also enable radically new types of systems because we're no longer constrained to the two-dimensional chips that we are constrained to today. So for instance, if we take this example I gave of millions of carbon nanotube sensors built on top of memory, built on top of more logic, built on top of silicon, these types of systems, which we've already built, can capture terabytes of information each second from the outside world, store that in on-chip memory, and then compute on it all in real time, transforming this massive amount of data I've captured from the outside world into actual useful, highly processed information that I can then send on and do processing on.